In this video, I'm going to cover section 4.10 and 4.11. So here 4.10 is introduce the Lognormal distribution. So what is a Lognormal distribution? So Lognormal distribution is similar to Weibull distribution, and we learned in 4.9. So then but Lognormal distribution is a little bit more easier than the variable distribution regarding the computation. So in Lognormal distribution, the random variable x is expressed as the exponential of the other random variable, and the other random variable is a normal distribution. So here, let's see. So as you can see that here, the variables in a system follow an exponential relationship as x is equal to e to the w. So the x has x and w, two variables or random variables, okay? And there is a relationship between x and w, which is this: x is equal to e to the w. Then the exponent is a random, w is also a random variable, right? I told you. And then now W has a normal distribution. Okay, so in that then the distribution x is called the Lognormal distribution, and then the name followed from the transformation of this natural log x is called W. Okay. Uh. Okay. So why do we need this? Natural log x is equals W. Because to find the probability of x, we're gonna transform the that probability to the standard normal probability under the standard normal distribution, so that we can find the probability easily. So let's see. So let's see here, low normal distribution. Suppose that W is normally distributed with the mean theta and the variance is omega square. Okay, then the CDF gonna be this, right? Here, probability x is less than or equals x. Okay, so this is probability of the log normal random variable x. Okay, now since the x can be expressed as the e to the w, so we're gonna substitute e to the w into x. Okay, so then we're gonna get this. Now, since the w has a normal distribution, so we're gonna take a natural log on both sides in an inequality. Then we'll get this. Now we're gonna find out g square of w and the g square of natural x. Then we get this, right? So then look at this. What is this? This is equal to what? That is equal to what? The definite integral 0 through the what? Natural x minus theta over the, yeah, this is, I mean, here, this is not, that's a typo, okay? Not just x. But this is 0 to, and definite integral from 0 to what? Natural x minus theta over omega of f of x. Here, f of x is what? The PDF of standard normal distribution. Okay, and then the z. Okay, this is not f of x but f of z, and then this dz. So the plug in the formula definition of the f of z, okay, here, and they calculate that definite integral. All right, then we'll get this. Okay, excuse me. All right, then we're gonna get this 1 over x times omega times square root 2 pi in the e to the this. Okay, so that's the PDF of log normal distribution, and the mean is the mean of the log normal is e to the theta plus omega square over 2, and then variance is e to the 2 theta plus omega square times e to the omega square minus 1. Okay, So lifetime of the product that degrades over time is often modeled by the Lognormal random variable. Okay. So example is lifetime of the semiconductor laser. Yeah, label distribution can be used. Okay, with the parameter delta and beta. Okay. What about low normal distribution? I told you it is easy to understand and easy to evaluate probability because low normal distribution is derived from a simple exponential function of normal distribution. Okay, so that's the reason. And let's see example 4.22. Let's see. Oh, okay, so now then 4.22 example right there. So let's see a second. Okay, example 4.22 semiconductor laser. So lifetime in hours of semiconductor, excuse me. So conductor laser has a low normal distribution with theta equals 10, omega is 1.5. And then what is the probability that lifetime exceeds 10,000 hours? So what we're gonna do, we need to we need to compute the probability that x is greater than, see that, greater than 10,000. Okay. Now we're gonna rewrite this one, we're gonna express this one in terms of CDF, which is 1 minus probability that x is less than or equals 10,000. But x is nothing but what, e to the w, right? And then take the integral, take a natural log on both sides in inequality, then we're gonna get this. Okay. Now then what? Since w, random variable w, follow the normal distribution, so we find a g-score. Okay, that's gonna be z is less than or equals in the natural log 10,000 minus 10 over 1.5. Okay, so now the using the normal CTFP calculator, you can figure out this value, that probability, which is 0.3, and then subtract that 0.3 from 1, that you get the 0.7. Okay. Now next one, what lifetime is exceeded the 99% of laser? So you can see that probability is given. We need to determine x, yes. Okay. Then we're gonna plug in e to the, we're gonna express x as e to the w, take a natural log, so we got this. Okay, and then find out g-score of the natural x, which is this. This is g-score of the g-score of natural x. So now, then we using the what? The what? Using the wait a second. So in this case, using the calculator, you can find out x value, right? Okay. How can I do that? Let me show you. Let's see here a second. So now here, what we're going to do is the probability that, let me do it in a new paper. Okay. So we want to find the probability that x is greater than x, right? So this is equal to probability that e to the w is greater than x, right? So that is equal to probability that w is greater than natural log of x, right? Okay. And that is equal to what? See here, natural x. Yeah. So that is equal to, because we're gonna use a command in the calculator, so we don't have to express this one. We don't have to apply the complementary rule, okay? As what textbook did, okay? So this is equal to 0.99. All right. Then what? So here we're gonna use inverse norm. go to distribution, then see here is inverse norm, right? So area is 0.99, and then mu 0, sigma 1. Okay, that's going to be 2.3263 approximately. Okay, so approximately 2.33. Okay, what does that mean? So what we got is the this is the standard graph of standard normal distribution. So mu is 0, and sigma is 1. Okay, so the here inverse norm find the z-score whose area from negative infinity to that z-score is 0.99. Okay, so area from under the graph of the PDF of the standard normal distribution from negative infinity to that z-score, which is 2.33 approximately. Okay, so that's the what 0.99. Okay, so this is 0.99. Right, but we want to find out what. So I mean, let me transform this one to the standard normal distribution. Okay, so z-score is greater than natural log x minus theta over omega. Okay, so we're gonna find out. We need to find out what probability. We need to figure out the this one where this probability is 0.99. Okay, then this value must be what? Negative 2.33. Okay, why? Because in normal distribution, and also not just normal distribution, has the graph of the normal distribution has a bell shape and is symmetric about the middle. Symmetric about the middle. It means that what area from negative 2.33 to infinity is also 0.999. Okay, area from negative 2.33 to infinity is also 0.99 because the graph is symmetric about the middle. Okay, so the probability that z-score is greater than negative 0.233 is 0.99. Okay, it means that natural log x minus theta over omega must be negative 2.33. So we got that equation. Natural log of x minus theta over omega is equal to negative 2.33. Okay, the theta is given and omega is given, which is 10, which are 10 and 1.5. So substitute them into the fraction. We got this. Natural x minus 10 over 1.5 is equal to negative 2.33. So now then what? We solve the equation for natural x. Okay, so this is going to be, excuse me. So let's see, it's going to be what? Negative 2.33. Okay, negative 2.33 times 1.5. Okay, and then plus 10. So I got the 6.505. Okay, and then the x is going to be what? E to the what? 6.505. Okay, so approximately this is going to be 668.48 hours. Okay, so now and then let's see, and then the example in the question asks you to find out the mean and standard deviation of lifetime. Yeah, just simply apply the formula of the mean and variance. Okay, that you can find out. So and then so next one, give me a second. Okay, next section is 4.11 beta distribution. So let me cover this one briefly. Okay, so because as you can see that the PDF is quite complicated, so you might I don't think you can uh, when you find a probability, I don't think you can do by hand. So you definitely need a calculator. Okay. So what's a beta distribution? It's continuous distribution. Okay, that is flexible but bounded over a finite range is useful for probability models. So that's the the useful the beta distribution is useful for the continuous random variable bounded over finite range. Okay, so now then the PDF is given like this. Gamma function is involved. Okay, so then gamma alpha plus beta over gamma alpha, and then gamma beta x to the alpha minus 1 minus x to the beta minus 1. So now depending on the parameter value of parameter alpha beta, we're gonna have different, the model of the beta distribution. So let's see example 4.23. So the service of the constant velocity joint in an automobile requires the sum assembly, both replacement and assembly. Suppose that the proportion of the total service time for this assembly follows a beta distribution with alpha 2.5 and the beta is 1. So what is the probability that this assembly proportion exceeds 0.7? So here, random variable x denote what? Proportion of service time for this assembly. Okay. So then probability x is greater than 0.7. Yeah, there's no this the simple way. Okay, alternative way to evaluate this. We have to use the f of x. Okay, so this is enter depth integral 0.6 depth integral from 0.7 to 1, and then f of x. Okay, so then yeah, that definitely you need to use calculator. Okay, so now next one, the mean and variance was given like this: alpha over alpha plus beta, and then alpha times beta over alpha plus beta squared times alpha plus beta plus 1. So the so normally the problems involved of the beta distribution, the problems mentioned that this is a problem about the beta distribution. Okay, so then you have to use the have to apply the f of x or the mu and the sigma squared formulas. Okay, so let me stop here. So if you have any questions about the homework, the work, quiz, just let me know.